Welcome to Tubig Online School in collaboration with Confidence Publications. All rights reserved. Neither complete nor in parts. This tutorial may be duplicated in any form by cut, copy, paste, camera, screen recording or any other means, or incorporated into any electronic or mechanical or digital system without permission. Today's topic for the lecture is absorption of UV radiation by aromatic amino acids. So let's quickly switch to our work area. So today we will be dealing with the topic absorption of UV radiations by aromatic amino acids. So let us analyze first of all our topic. Our topic is for the discussion is absorption of UV radiations by aromatic amino acids. So aromatic amino acids, why aromatic amino acids absorb UV radiation? Aromatic amino acids absorb radiation because in the aromatic amino acids the side chain contains the aromatic ring or benzene ring or alternate double bond ring. So which amino acids absorb? These are tryptophan, tyrosine and phenylalanine. So these three amino acids are the amino acids which absorb UV radiation because of their aromatic side chain. So now how much absorption? Absorption depends upon the number and position of the double bonds. So it is common to every organic molecule. The molecule which has alternate double bonds and can resonate in the UV spectra absorbs UV radiation. So here protein also have alternate double bonds because they have a aromatic side chain, so they absorb. So here is a graph which shows the absorption of the tyrosine and tryptophan. So let me switch some color and then I will tell you. Okay, so you can see here the tyrosine is on the x-axis there is the wavelength, and on the y-axis there is extinction coefficient. Extinction coefficient is measured in per mole, per molal or molarity, okay, and per centimeter. It's molarity, okay. So its molarity is the unit of concentration. So extinction coefficient is per molarity per centimeter. Now switching to main content is what we have to see the absorption spectra. So this is hand drawn by me. This is not to scale, but what I am trying to make out, please concentrate on that. You see this is around 280. Tryptophan has a maxima, and tyrosine has a maxima and tryptophan has a maxima. Okay, so but you see the tryptophan absorbs 4 times as much as tyrosine. Again, this is not as scale, but you can imagine if this is and then there will be 3 more. So tryptophan absorbs 4 times as much as tyrosine. So we can see, look at the phenylalanine. Phenylalanine absorbs at 257 nanometer, tyrosine absorbs at 274.6 nanometer, and tryptophan, the most important one, it absorbs at 279.8 nanometer, which is around 280 nanometer. So this property is most useful in the quantification of the proteins. So that's all for this lecture. Thank you for watching as always.